All right, so in our last lesson, I unfortunately wasn't able to be here, but Marilise, I know, did an absolutely fantastic job. And of course, Yolanda was there as well. And one of the things that we need to cover before we can move on to the next section, this is really important when it comes to analytical geometry, is the concept about lines and circles. All right, so what they expect you to be able to do is they expect you to be able to determine the point of intersection between a straight line and a circle. And in order to be able to do this, you are going to be solving simultaneously. Okay, so being able to solve simultaneously between a straight line and a circle is very, very important. So this is what we're going to talk about and practice before we move on to tangents of circles. So a really super simple example for you to get started with. The first equation they give us is the one of the straight line. It is the line y equals x plus 1. So we all know that that is a straight line, a diagonal straight line with a positive gradient, and it intersects the circle x squared plus y squared equals 25. They want us to determine the coordinates at the point of intersection. Okay, so any idea what it is I should write? Does anybody want to tell me what you think I should write here? How should I solve simultaneously? What do I need to show? Anybody want to tell me? What do you guys think? Are we all feeling shy tonight? You guys have solved simultaneously before by substitution. This is no different. Any takers?
We can do this, guys. Want us to push.
I think there is someone. Okay, Palesa says sub x plus 1 into the equation. Absolutely. So what should I write, Palesa? Tell me what I should write.
Afternoon, ma'am.
Afternoon, Palesa.
Okay, ma'am. I think you should write x squared plus x plus 1 squared is equals to 25.
Lovely. Perfect. Okay, so that's exactly it. That's cracking the first line. Okay, the rest of this after this is all just mechanical maths. All right, so we would need to remove our brackets, collect all our terms on one side. In other words, get it into standard form, and then we could go and factorize from there. So if I write x squared, and then here, if I square my binomial, is everybody up to scratch? If I write x squared plus 2x plus 1, that's me squaring my binomial, and I'm bringing the 25 over from the other side. Okay, so this is going to leave us with 2x squared plus 2x can be combined with any other terms, and if I have 1 minus 25, I would end up with negative 24. Okay, then after that, I've got two options at this point. Either you can use the quadratic formula if your factorizing is not great. Otherwise, the easiest thing to do would be to divide through by 2. That gives you x squared plus x minus 12 is equal to 0, and then we would factorize. So because our middle term is positive, the bigger of our two numbers is the positive one, and the smaller number will be negative. So two solutions for x. Either it is negative 4 or x is equal to 3. Okay. You can either use the straight line or the circle to work out the coordinate of y. Okay, the easiest thing for you to do is to use the straight line. So you would go and sub in for y now. So y equals x is minus 4 plus 1. We would end up with negative 3. So here we've got negative 4 and negative 3 as one point of intersection. Okay, and the other one is 3 plus 1, so that would give us 4 as an answer. So here we would have 3 and 4, and those would be our points of intersection. Are we all good with that? Are there any questions? Is there anything that anybody needs to ask before we move on? Let's have a look. There's some hands up here. Yuliswa, go for it. What's your question?
Ma'am, can you
Mm.
please explain this to me again?
Okay, Yuliswa, you need to be more specific. What is it that you didn't understand?
Can you explain it from the beginning?
No, but what don't you understand? What is it that you don't understand? Do you not understand the substitution?
Yes, I don't understand the substitution.
Okay, so in order to be able to solve for any equation, you need to have only the same variables in equation. So if y is equal to x plus 1, then where you see y over here, you're replacing it with x
Oh,
plus
you
1.
substitute X.
Yeah,
Okay,
yeah.
okay, I get
Okay.
it. Thank you.
Okay. All right. So maybe
Thank you.
it was much easier than you actually thought. Okay. So I'm subbing, this is equation number 1, and I'm subbing it into equation number 2. Okay. All right. Bonga, do you have a question?
Yes, ma'am. I wanted to ask why are we adding +1 to the -4 and +3?
Oh, because you're using this equation over here to solve for the corresponding y coordinate. Okay, so that's what I'm subbing into. This is x plus 1. Y equals x plus 1. Over here,
Oh,
y
okay, I
equals
see
x
now.
plus 1. Okay, so I'm just subbing back into the other equation. So, guys, when you solve simultaneously, all right, and you've got a linear equation like y equals x plus 1 and a quadratic equation like the one of a circle, you're always going to sub the linear into the quadratic, never the other way around. Okay, and then when you go back, it's just easier to use the linear equation to solve the y coordinate rather than the quadratic one. It just makes it quicker and easier for you. Okay, it is. It's exactly like simultaneous equations. Absolutely. So like in that first question, question number 1, where they ask you to solve for x, it's exactly the same thing. All right, so for something like this, there would be a mark for subbing in, getting it into standard form, factorizing, getting your x's, getting your y's. Okay, all right, we're going to use this quite a lot this evening, so if you're feeling a bit nervous about this, don't stress, you're going to get a chance to practice this. Okay, so what's important for us to note is that when you have or when you are solving these sorts of equations, there are 3 possible outcomes that you can get. Either you end up with 2 pairs of solutions like we did now in this example that I did with you, or you end up with 1 pair of solutions, or you end up with no solution at all, right? And each of these 3 things means something, right? So if you have 2 pairs of solutions, it means that there are 2 points of intersection. Okay, in other words, your straight line is called a secant. Okay, it cuts your circle in 2 places. If you end up with 1 solution, it means there is 1 point of intersection, and here your straight line is referred to as a tangent. Now that's a word that a lot of us have heard before, okay, because we've spoken about tangents in Euclidean geometry. In grade 11, we've spoken about tangents to functions when we do functions, etc., etc. Or you could end up with there is no solution. All right, so no real solution. And that means that there is no point of intersection between the straight line and the circle. Okay, so this is just a straight line. It doesn't have a special name or anything like that. And clearly there would be no real solution because I beg your pardon, because the straight line is not touching the circle. So please take a screenshot of this. This is an important piece of information. Let me just move it down a little bit so that you can get all of that on screen at the same time. Yes, Pinga, but I would be very, very surprised if they would even ask you a question about that, Pinga. Because you know the whole idea behind this is that they want you to get a solution. Okay, so you know questions involving a line that doesn't intersect the circle are very, very, very unusual. Okay, but yes, that's what would happen. So you'd end up with something like x squared equals root minus 4. or whatever. Okay, so there would be no real solution. Okay, Pinga, does that make sense? Okay, so screenshots, everybody. These points here are important. I'm going to move on to the next thing now. Okay, so another piece of important information that I suggest you screenshot: if you are given the equations of a circle and a straight line, and you are required to prove that the straight line is a tangent to the circle, then all you need to show is that there is only one point of intersection between the two graphs. Okay, so questions like that come up, especially in control tests or assignments, that kind of thing. So please make sure that you screenshot that as well. All right, so if they ask you to prove that a straight line is a tangent to a circle, you do this by showing that there is only one point of intersection between the two graphs. Okay, are we all good so far? Thumbs up, thumbs down. Are we feeling okay? We ready to put this into practice? Cool. All right, lovely, everybody. Let's go and have a look at the questions we need to answer. Excellent. Okay. All right. So now, I am giving you a choice. All right. Either you are going to do question 1.3 or you are going to do question 1.4. Neither of them. Tendai, please.
Sorry, Teacher Lee, I just muted everybody. You can unmute,
That's
guys. If you don't
absolutely
behave,
fine.
I'll mute everyone, and you won't have any power at all to unmute yourself. So let's behave.
Yeah,
And let's
please.
do this.
Obviously, this is meant for the offenders. It's not for the people that do the right thing. Please, guys, you have to stay on mute. If you end up talking or we can hear people in the background, it just disturbs the experience for the other students that are here. So please, let's just all be considerate of one another and make sure that unless we're asking a question, we stay on mute. Okay, so you guys have a choice here. Either you're going to do question 1.3 or you're going to do question 1.4. All right. What I have done here is I have made these questions not more difficult, but just slightly more difficult than the question that I did the example of. All right. So remember, you are subbing the linear equation into the circle. So question 1.3 would basically be the easier of the two. So that's going to get a green light. And question 1.4 would be the slightly more difficult one. So that's going to get an orange light. When you are finished, please put the word done into the chat, and then we will go from there. If you need any assistance, Yolanda and I are here to help you. Okay, ready, steady, go.
And when we're done, we can put it on the chat and say done, so Teacher Lee and I can see it. You are doing really good.
Tenda, you got a question? You're welcome to unmute and ask. Tendai, if you want to ask a question, you're welcome to unmute and speak.
And is that hand? There we go. You want to ask
Okay.
a question?
Mm-hmm.
You can talk. Hi.
Yes. I don't understand question 1.3. Like how I was supposed to do it.
Okay, you're supposed to substitute like I've just shown you, all right? But you've got to make, you've got to take which one is the linear equation?
Is it 2y plus x is equals to 7?
Lovely. Okay, so now make x the subject to the formula. What would you write?
Let me write it. It's going x is equals to 7 minus 2y.
Beautiful, lovely. Okay, now where do you see x in the previous equation? You see it over there, don't you? I've put a little green
Yes,
ring
ma'am.
around it. Okay, so what you're going to do is that instead of writing x, you're going to write 7
minus 2y.
minus 2y minus 1 squared plus y plus 2
plus
squared is equal to 20.
20.
Okay, so now you've rearranged and you've subbed in. You've got like terms inside this bracket over here, so you can simplify that first if you want to. So what you can do, if you like, is bring the minus 2y to the front because there's no like terms. 7 minus 1 leaves us with 6. Okay, and then you can go from there, Tendai.
Thank you, ma'am.
Okay, no problem.
We have Glendy next. Glendy's hand is up.
Sure, Glendy, go for it.
Okay, ma'am, I wanted to explain it to the person.
I beg your pardon?
I wanted to explain to the person.
Oh, you wanted to explain to that. Oh, okay. Sorry. Okay. All right. No problem.
Mhm.
I'm not sure if we can actually, Yolanda, is that possible? Can we have a one student explaining to another student? I suppose if I give,
Not,
I suppose if I,
not exactly per se, because it just depends. But I mean,
Ma'am, can I ask,
you can
yes,
ask.
reliable.
what was the question?
Okay, so Tendai said he didn't understand how to get started with question 1.3. So I was
Okay.
just showing him how to make x the subject to the formula in the linear equation and how to sub it into the quadratic equation, the one for the circle.
Okay.
Okay,
So should I explain it to him?
it's all right. I think I've explained it to him already. What I'm just waiting for from you guys is if you've chosen to do 1.3, that you've got some answers, and then, or if you chose to do 1.4, that you've got some answers.
Okay, ma'am. Now I'm still working on 1.3.
That's fine. You keep working, and then when you're done, you can put done in the chat. Kamachelo, I see you put done in the chat. Did you do, which one did you do, Kamachelo?
Hi, ma'am.
Hi, Kamachelo. How are you?
I'm writing yourself.
Fine, thank you. Which question did you do, 1.3 or 1.4?
I did both, but I'm not
Oh,
quite
you,
sure about my 1.4.
all
My
right,
1.3,
that's,
I got 3 and
Okay,
2.
don't share your answers just yet. That's fine. That's fine. I know. Well done.
I'm
That's really, really good.
sorry.
No. Don't say sorry. It's fine. It's just that I know other people get put off when they hear the answers. So I tell you what I'm going to do, Kamogelo. Why don't you try question 2 or question 3 in the meantime? Okay, just while you're waiting for everybody else, and then at least you're still busy. Okay.
All right, ma'am.
Well done. Well done for working so hard. Okay.
Mm.
Okay, so I'm just going to wait for a few more dones before we. Okay. Is it Zedalia? I hope I pronounced your name correctly.
Hi, ma'am. Yes, you did.
Oh, good.
I just wanted to ask, ma'am, am I correct to say that we use the quadratic formula somewhere? I just want to know if I'm on the correct track.
You can absolutely use the quadratic formula.
Okay, perfect.
So what
Thank
you would
so
do
much.
is you'd wait until it was in standard form,
Yes.
and then use the quadratic formula.
Yes, ma'am.
Perfect.
Thank you so much, ma'am.
Pleasure.
It was because Teacher Lee was talking to, yeah, I can't remember the name, but on their
Zedalia.
side they had the echo. Yes, they had
Yeah.
the echo, but now it should be sorted.
Yes, it should be gone. Okay. So I'm going to get on with question 1.3. Zedalia, please do not apologize. Okay, it's no problem at all. It's just like Kamogelo, don't apologize for things like that. It's no worries at all. Okay, it's not so it was done on purpose. Okay, so in question 1.3, right, we would need to expand our brackets. I'm just wondering, instead of me talking, let's just see if somebody else can rather do this. Is there somebody who did 1.3 that would like to take us through how they did this? Anybody? Anybody feeling?
Ma'am, can I speak?
Go for it.
Oh, ma'am, I did a mistake.
Oh, okay. What mistake did you make? Is this in question 1.3?
Ma'am?
Yes.
Mama, I forgot to write 20.
Okay. All right.
That
So then if
made
you
my
left,
whole equation wrong.
yes, it would make your whole thing wrong. Don't worry, I did that earlier as well. I also made it equal to 0, and there was supposed to be a number there, and I didn't end up doing that. Okay. All right. So when we square this binomial, we would have ended up with 4y squared minus 24y plus 36. Over here, we would have ended up with y squared plus 4y plus 4, and then we needed to bring the 20 over from the other side. Let me just double check that I've squared this correctly. 4y squared, yes. Okay, so now we would end up with 5y squared matrix minus 20y, and then
Plus
36
20.
plus 4 would be plus 20, quite right.
Equals to 0.
Equals to 0. That's a Tendai. And then what did you do at this step over here, Tendai?
I use the quadratic formula.
Use the quadratic formula. Fine. So you said y equals
Is equals to
negative
minus
b
20 plus or minus square root 20 negative 20 squared minus 5
4
minus 4
times
times 5
times
20.
Good. All over
2 times 5
2 times 5, absolutely. If you factorize, just 1 second, Teda, if you factorized instead, there's absolutely nothing wrong with that either. Okay, so you could have divided through by 5 and then factorized. Let me just show that for anybody who may have done that. Okay, so your other alternative here would be to divide through by 5. Sorry, 20 divided by 5 is not 5. 20 divided by 5 is 4. Okay, and then you could have factorized. Okay, so Tenda, what did you end up with as an answer?
Y is equals to 2 or 2.
Y is equal to 2 or 2. So in other words, there's only one solution for Y. Okay, and that makes sense because this is a perfect square trinomial. Okay, so here you would have had Y minus 2 times Y minus 2. So yes, so Y was equal to 2. Absolutely. Okay, so we're getting one solution for Y. That means we're going to get one solution for X. What was your solution for X, Tendai?
For X is, I'm still doing it, man.
Okay. Sorry, yes, it should. There we go. There we go. So then when we worked out X, X would have been?
Okay.
Yes, there we go. Quite right. Sedalia, me too. Okay, so one set of solutions or one point of intersection in question 1.3. Okay, so we should have got 3
Yes. Okay, I got it.
and 2. Okay, what does this tell us about the line 2y plus x equals 7 and the circle? If there is just one point of intersection, what does that mean? The straight line is a, that's it, Lorato, it is a tangent. Yes. Okay, very good. Well done. All right, let's have a look at 1.4 now. Anybody do 1.4 and is feeling brave? And let's see who's got hands up. Okay, Kamgelo, all yours.
Ma'am, I want to ask about 1.3.
Sure.
You see now we got that it touches the circle at one point, which means it's a
Yes.
tangent.
Yes.
Could we be asked if whether like you see last on our previous session we were doing if
Yes.
it's the points lie on the
point.
circle.
Yes.
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 So could we be asked a question like that if whether the points lie on the circle in or outside?
Yes, absolutely. Absolutely. So they could ask you a question about whether the point lies inside, on, or outside the circle, and they could also ask you a question like this. Okay, whether, calculate the point of intersection, and then is it a secant or is it a tangent or is there no point of intersection? These sorts of questions would probably be more common in tests. An exam question would probably be more similar to like question 3, where it says, show that this is a tangent to a circle.
Oh, all right, ma'am. Thank you.
Okay. All right. No problem. Does that mean I need to do 1.4? Is there somebody who wants to tell me what to write for number 1.4? Why is it a tangent? Okay, because if we go up here, if there is only one point of intersection, then it means that the straight line only touches the circle once, making the straight line a tangent. Okay, so it comes from this theory over here. Okay. All right, any takers for 1.4? Anyone feeling brave and wants to do 1.4?
I'm still doing.
All right, if no one's feeling brave, it doesn't matter. I'll show you guys how we would answer this question. Again, Lorato, do you want to do it?
Hi, ma'am.
Hi.
Ma'am, I'd like to try.
Oh, awesome. I'm so pleased. Go right ahead. Tell me what you think I should write.
Okay, so first let's form an equation using the smaller
Absolutely.
X
Go
plus
for it.
5 is equals to 8.
Mm-hmm.
X is equals to 8 minus 5. Okay. And then x squared
Good. Yes.
minus x plus y squared minus 3y minus 4 is equals to 0. Now we are going to
Lovely.
sub in we're going to sub in place of x, we'll put 8 minus 5y.
Lovely.
Go ahead.
Okay, go for it.
And then 64.
It's just, sorry, I'm just clearing some space here. Lovely. 64, yes.
Minus 40y.
Minus, so when you do it like this, you've got to remember to double it. Okay, so it's not going to be minus 40y, it's going to be minus 80y.
Okay, minus 80y minus 80y
Yes.
then.
Yes. Keep going.
Plus 25 squared.
Y squared, lovely.
And then minus 8 minus
Yes.
5y.
So
Plus
plus
y
5,
squared.
because a negative times a negative is a positive. Good.
Yeah, plus y squared minus 3y minus 4.
Beautiful. Well done. Perfect. Okay, so now what would I do?
Ma'am, I collected like terms.
Absolutely. So if everything that I've done here is correct, and I'm sure Yolanda's keeping an eagle eye on what I'm writing. Yolanda, I hope I haven't made any mistakes so far. We would end up with 26y squared. And then as far as our y's are concerned, we've got a y term here, a y term here, and a y term here. So that is going to leave us with, is it minus 78y?
It can't be 70. Whoa, okay, there's a minus 3 there. Sorry, I'm also like calculating. I'm like,
No,
oh.
that's fine. I just don't want to make any mistakes here. I don't think we have so far. And then we've got minus 8 minus 4, which should be minus 12. Okay, so 64 minus 80y plus 25y squared minus 8 plus 5y plus y squared minus 3y minus 4 equals 0. Okay, so now
Sorry,
let's
what
not.
happened to the 64? Sorry, maybe I'm not seeing
Yes, what
correct.
no, you're right. What happened to the 64? You're quite right. My
Yeah.
mistake. It's why I'm asking you to keep an eagle eye on me. Okay, so we've got 64 minus 8 minus 4. So it's going to be 64 minus 12. It's just 80. Okay, and now we've got 64 minus 8. And 64 minus 8 minus 4. And that leaves us with 52.
Yes, 52. It's positive 52 though.
It is positive 52, quite right. Okay, so I think we've got this correct. Yulisa, have I made a mistake?
Oh no, ma'am. I just also wanted to help.
Oh, okay. It's fine. I think we've got this correct now.
I think on the chart, you should just check the signs. I understand why you think it's 72 or why is negative 88y. but check your sign, please.
Okay, so what we would have is we would have the 25y squared and the y squared over there. That would give us the 26y squared. Let's just use some different colors. Then we've got minus 80y plus 5y minus 3y, which gives us this minus 78y. And then the last one, let's just use a nicer color. Let's go with that pink. We've got 64 minus 8 minus 4, which gives us the plus 52. Okay, so I'm feeling pretty confident that we have now got that correct. Okay, so now we can either sub it into the quadratic formula, or we can go ahead and go and factorize. All right, I think
Penda has a question. I'm not sure,
Sure.
but he's
sure.
Tenda, you can unmute and talk.
No, I was just saying I was done with 1.4 on.
That's fine. Perfect. Is 78 divisible by 26? Yes, it is. Is 52 divisible by 26? Yes, it is. So this has actually worked out nicely here because we can divide every single term by 26. So we're going to end up with y squared minus 3y plus 2 equals 0. And that's going to be much easier for us to work with. So here we're going to end up with y minus 2 times y minus 1 equals 0. So either y is equal to 2 or y is equal to 1. Okay, matrix. So we've got two solutions for y. That means there have to be two solutions for x. So now we're going to go back. We're going to take this linear equation because it's the easier one to work with. X equals 8 minus 5y. So x equals 8 minus 5 times 2 is the one solution. So x would be equal to negative 10. Or the other solution, x equals 8 minus 5 times 1. So that would be equal to 3. So we've got 2 points of intersection. The one is negative 10 and 2. The other one is 3 and 1. Lorato, you got a question?
No, ma'am, mistake.
No? Okay. All right. Okay.
Sorry, ma'am.
Everybody happy with that? So you can see
Sorry, ma'am.
sometimes they get us to do some nasty. Is there somebody asking me a question?
Yes, ma'am.
Yes. Go for it.
When I subbed in the y equals 2 back into the 52 minus 78y plus 26y squared, I got like negative 280, which is not equal to the right-hand side. And then when I substituted the 1, it equaled to 0. So surely there's only one solution.
Let's just go back and go and check this. Okay, so we've made x the subject to the formula. We've taken that over to the other side. Let's just check our substituting.
No, ma'am, everything is fine. It's just that with the final answer,
yeah,
with the y equals 2 and the y equals 1, if you take the y equals 2 and you sub it back into the 26y squared minus 78y plus 52, you get negative 208, which is not equal to the right-hand side. So surely that's
okay.
not a solution.
Okay, let's just double check. I don't think I've done anything wrong here, but I do make mistakes. So let's just double check. So we're going to say 26 times. So it would be 2 squared.
Yeah.
Minus 78 times 2. Then don't forget we've got to have plus 52 on the end. Plus 52. That should give us, I'm getting an answer of 0.
Oh, sorry, ma'am.
Okay. It's okay.
Yeah.
No stress. I do make mistakes and I've got no problem with any of you guys asking questions or pointing out when I'm wrong. So no stress at all. Okay.
Thanks,
Trish, no problem. So Trish, you got negative 10 and 2 and minus 2 and 2. Trish, Because I'm an idiot, Trish, sorry. 8 minus 5 times 2 is 8 minus 10. Sorry, I'm writing this bit over here. 8 minus 10 is negative 2. You're quite right, Trish.
It's okay.
Sorry, guys. No, we don't need me making mistakes here. All right, I agree with you. Sorry, it was just a silly little thing over there. Okay, and then here 8 minus 5 times 1 is 3. There we go. Okay, my apologies, Matrix. Thank you. There we go. All right, guys. So you can see here, sometimes they ask us to do things with terrible numbers. All right, so we've just got to work very slowly and very carefully in order to get to the right answer. And even me, I need to be careful that I don't rush things and then end up writing stuff that isn't correct. Okay, how many marks would it be out of? Good question, Penga. Okay, so Penga, there's always going to be a mark for substituting in, right? So there would be a mark for this line over here for subbing in. Then I would imagine there would be a mark for this line over here. Okay, so either the 26y squared minus 78y plus 52, or on standard form over here, that line there, a mark for your factors, a mark for your y's, and a mark for your x's. So 1, 2, 3, 4, 5 marks. Okay, Penga. Kamgelo, you got a question? Kamgelo?
Oh, ma'am, I had made a mistake on substituting into my quadratic equation, so it wasn't giving me the right answers.
Wasn't giving you, yeah, absolutely. So, you know, when something like that happens, you just kind of got to go back and just work through each term and just make sure that you've multiplied correctly and that you've added correctly, or whatever the case is. Okay, so yeah, perfect. Well done. All right, so what I would like to show you, and we're sort of starting to run out of time now. We've only got 15 minutes left. We could just go on forever and ever and ever, couldn't we? Is I just want to show you how you would do a question like question number 3, where it says show that it is a tangent to a circle. Right, so it's simply just a matter. Yes, go for it. I'm not sure if I'm going to pronounce your name and do it any. Can I call you Kish? Do you mind?
Hi, ma'am.
Hi.
So firstly, hold on.
What would you do in
Okay.
question 3?
So firstly, we would calculate the equation of the center of the circle.
Okay, why?
The point of the center of the circle.
Why do you think you need to find the center of the circle first to answer this question?
Okay, so the proof that you need to make that it's a tangent to the circle is that the radius and the tangent need to be at 90 degrees. So it should be perpendicular.
Absolutely. Absolutely. But in this particular question, all right, all they want you to do is prove that this line is a tangent to a circle. So if you want to prove that a line is a tangent to a circle, all you have to do is a simultaneous solution. You don't have to get it into center radius form first, and just show that there is one point of intersection. Okay, so it's very similar. It's very similar to what we did in question 1.3. All right, so this is how, yeah, just one point of intersection. So what you would end up doing is something like this. Let me just clear some space here. And you see, unfortunately, in maths, if we interpret a question to mean something different than what we think it means, all right, and we do a whole bunch of working, we're not necessarily going to get marks for our working, because unless our working assists us in answering the question that's been asked, we're not going to get the marks. So in this particular case, completing the square is not going to help you. If you are going to complete the square, they need to be asking you for the coordinates at the center or the length of the radius. That's when you want to go and complete the square. Here, it's just a simultaneous solution, and you've got to show that there's one point of intersection. So in question 3, you would just go and sub in. You'd end up with x squared minus 2x plus y squared. So that would be 3x plus 5 squared plus 4y. So 4 times 3x plus 5. And then I've got to remember to bring down the minus 5 and make it equal to 0. Again, I'm just going to do multiplying out. So we'd end up with x squared minus 2x, squaring our binomial. We'd end up with 9x squared. 3x times 5 is 15x, so that would give us 30x in the middle, plus 25, plus 12x, plus 20, minus 5 equals 0. And now we can get it into standard form. Okay, so this would give us 10x squared. So that would be 28, and 28 plus 12 would leave us with 40, wouldn't it? Okay, so that's going to be plus 40x in the middle. And then here we've got 25 plus 20 minus 5. So that would give us, I haven't left out any numbers here. I'm just double checking. So 25 plus 20 would be 45. So that would be plus 40 equals 0. Then we can divide through by 10. This would give us x squared plus 4x plus 4. And now we know that we're correct because this is a perfect square trinomial. So it would factorize into x plus 2 squared equals 0. So therefore x equals -2. Okay, we can work out y. So y would be equal to 3 times -2 plus 5. So that would give us -1. So what we would then write now, matrix, is we would say, therefore, point of intersection. Oh, actually, let's say that a little bit better. Therefore, the coordinates at point of intersection are -2, -1. Therefore, the line is a tangent to the circle. Okay, because there's only one point of intersection. Okay. Yes. You're welcome to go ahead and ask.
Ma'am, so if they say prove that the tangent and the circle, would you have to then prove that it's equal to -1? The two gradients.
I'm not sure I'm following your question. Please, can you ask me that again? What exactly are you asking me?
So they say that show that the tangent.
The line is a tangent to the circle.
The line is a tangent to the circle, yes. Do we have to then prove, after finding the center, that the gradient of A and the gradient of B, or the two equations, are equal to -1?
No, you don't have to do that for this particular question. I am going to show you how to do that, but that will come up next week, but not in this particular question, no. So here, all they want you to do is they want you to do a simultaneous solution, end up with one pair of coordinates, one point of intersection, and based off of that, you would then conclude that the line y equals 3x plus 5 is a tangent to the circle, and that's all they're asking for. Okay.
Yes, ma'am.
All right. Any other questions? How do we answer question 2? All right, so question 2 relates back to what we did in question 1.3 and 1.4. Okay, so what did we end up with? I've rubbed it out now, so I don't have it in front of me. But if we ended up, I think in question 1.3, we ended up with one solution. So then what we would do is that we would say that the line 2y plus x equals 7 is a tangent to the circle. In 1.4, we ended up with 2 points. So we would say that the line x plus 5y equals 8 is a secant to the circle. That's what they were asking us in question 2. Okay. All right, let's see. Scroll down to the reason. That's fine, no problem. No problem. And just scroll down a little bit more.
Well done, Matrix. Y'all
Well
have done
done.
it again.
You certainly have. Are there any more questions that you guys want to ask? Sure. So Kamachelo, they were just asking us based off of our answers to 1.3 and 1.4, what was the relationship between the line and the circle? So in 1.3, we had 1 point of intersection. So that line was a tangent to the circle. In 1.4, we had 2 points of intersection. So that line was a secant to the circle. Okay, that's all. So Tendai, when they say a line is a tangent to the circle, it means it only touches the circle in one place. Okay, so if we go back up here and have a look at this, a tangent only touches a circle in one place. It's this middle one over here. Okay, that's what we mean by a tangent. Okay, so it touches the circumference of the circle in one place only. How many marks would question 3 be? Good question. Okay, so again, there would have to be a mark for subbing in, standard form, factors, and then getting 1 point of intersection. So this whole thing here, getting 1 point of intersection together with the explanation would be 1 more mark. So I would say that would be out of about 4. Okay. All right, so we finished in time for me to give you guys a little bit of homework. Okay, take a screenshot of this question over here. Let me just make it a little bit smaller so that you can get all of it in. Hang on 1 second. There we go. This is your homework for next time. Okay, so please take a screenshot. This is homework for the next lesson. Okay, Matrix.